Hi, I'm Mary, and this is another magical math moment. In this video, we are going to start exploring sinusoidal transformations, and we're going to be talking about the different parameters and how it impacts how the graph looks. So we're going to start with A in our general form here. So if you've got a number out front, that's going to impact the amplitude. Remember, amplitude is the height of the graph, and the amplitude itself, the A value is always positive. Now, when you're sketching this thing, a positive number out front is going to have like a normal type of graph, and a negative out front is going to flip the graph or reflect it over the x-axis, okay? We are also going to talk a little bit about B, which is the period change. So a normal period for a sine or cosine function is 2 pi, because it starts at 0 and goes out to 2 pi, which is a length of 2 pi. If there is a number that's inside here, in front is a coefficient to x, that's going to impact the period, which then impacts the length of the graph. So maybe going from 0 to 2 pi might now change from 0 to pi, or it might increase 0 to 3 pi. It all depends on what the number is. Another parameter that we have that we're not going to discuss in this video is C, which is the phase shift. It's very much like other functions where that's your horizontal shift left or right. Just like other functions, when you've got a grouping symbol, the shift is going to be the opposite of what it appears. Phase shift is a little sneaky, so we're going to do a separate video on that altogether, as well as putting everything together. The last parameter is D, and that's your vertical shift. Just like every other function you've ever dealt with, positive means it's going to shift up, negative it shifts down. This impacts the midline's location, and we're going to get right to it so you can see what I'm talking about. All right, in our first graph here, we have y equals sine x plus 3. So as we're thinking about this, this is a D value of 3. That means we're going to be going up 3 then from where we normally are. So normally we might be here, but we are going to shift up 3. So we're going to go up 1, 2, 3. I'm going to go ahead and make a dotted line here. Y equals 3. That's my new midline. Normally that's at the axis, but we're shifting up. Now remember the max and min values of sine. We're going to be going up 1 as well as down 1. And then we're also going to be going over on our x-axis. Remember, this value is 1, here's 2. We obviously have 3 and 4 here. So if you want it to be kind of accurate, if I kind of go down this way here, pi over 2 is going to be my first one, which is like 1.5. So I want to kind of like go over a little bit. So maybe like here, this is pi over 2. Then we're going to go about the same pi. Here we are at 3 pi over 2. And then finally at the end, 2 pi. Okay, so let's see what's going on with this function. All right, so sine we know always starts at the midline, then it goes up to the max, back down to the midline, down to the minimum, and back up to the midline. All right, we're gonna do our curve. Ooh, don't judge, this is kind of hard at this angle. All right, and there's our sine curve. So we've just taken the sine graph and shifted it up 3. That's it, not too bad, right? How about we have cosine x minus 1? Much to what you would probably think here, the D value is -1, which means I'm going down 1 this time. So if I have my normal axis here, I'm just going to shift down 1. Up, 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 up. Y equals -1. I also need to go down here for -2 because I have a max of 1 and -2 or 1 and -1 normally. Since it's shifted, the max is now 0. The min will be down here at -2. So let's go ahead and get over here. Pi over 2. Here's pi. Oh, this is going to be a little wider than I was thinking. 3 pi over 2. Oh, that's not even. And then 2 pi's over here somewhere. So we're going to stretch this out. Some students like to use graph paper, which I maybe should do that because this is really not that even, but that's okay. This is just a general sketch so you guys have an idea of what's going on. All right, cosine graphs always start up at the max. So in this case, we're starting here at 0. At pi over 2, we're at the midline. At pi, we're down to the minimum. 3 pi over 2 back to the midline, and at 2 pi finally up to the max. So here we go. Oh boy, that is something. So you can see this is a normal cosine graph. I don't know how normal that is, but it's been shifted down 1. All right, that's the easy stuff. Then we get into amplitude, which is also not horrible, but it's a little bit weird. This A value is actually 4. So the amplitude is 4 because it's a height. Height's positive. The negative is going to reflect it over the x-axis. All right, so just be careful of that. So we're going to be taking our cosine graph, flipping it over, and then stretching it a little bit. So here we go. Make sure I have enough space for this thing. All right, normally the max is -1. I'm sorry, the max is 1, the min is -1. However, we're dealing with 4 here. So I know I'm going to be going up 1, 2, 3, 4, as well as down -1, -2, -3, -4. All right. Here is going to be pi over 2. Here is going to be pi. Here's 3 pi over 2. And finally, 2 pi. All right, let's see what happens. All right, normally cosine starts high, but because this is a negative, we're gonna start low. So we're down here, then we're at the midline, then we're at the max, then we're back down here at the midline, and finally at the min. This is gonna curve up, cut through there, curve around, go like that. And I'm gonna move this so I can make it pretty. There we go. That's not even. Well, you get the general idea. Yeah, this should be up a little bit higher. So let's do that. That looks nicer, doesn't it? Get rid of that. Okay, that's still kind of flat, but again, not using graph paper, general sketch, so you get the idea here. The negative flipped it over, so we start low, and then you can see easily here that the amplitude is 4. And it looks like a mountain. All right, how about if we have y equal to 2 sine x? This time the amplitude is 2. It's going to be a normal looking graph. So let's do this and see what happens. All right, so we're going to go up 1, 2 this time, down -1, down -2. Then we're going to go over here to pi over 2. And then we're at pi. And then over here, we're at 3 pi over 2. And finally at 2 pi. Okay. Sine starts at the midline, which is right here on the axis. Then we're going to go up 2, back to the midline, down to -2, and then back to the midline. So we're going to do our sketch like so. Some textbooks, when they have you do this, oh gosh, make it curvier. It's always this like 4th point for me. I don't know what that's about. Some textbooks also like you to draw the parent function in. So I usually would just do kind of like dotted line. That's what a normal sine curve looks like. So you can see the stretch here. Let's do that with the cosine one as well, so y'all can see that difference as well. If I do negative cosine, I would be going like so, so you can see the stretch on this one. So that's kind of neat. All right, here's where it amps up a little bit. It's kind of strange. Now we're talking about a period change. Normally when we're talking a period, that's how long one cycle of the graph is. So one period goes from 0 to 2 pi, 2 pi. This is going to be a little bit different. This is a b value of 2, and period is going to be equal to 2 pi over b. So in this case, it's 2 pi over 2, which means pi. So instead of going the entire thing of 2 pi, we're going to be kind of squishing the graph in, so it is going to be half the size it normally is. Okay, so again, let's see. Here's 1, here's -1. We're going over to what is this? Pi over, this is a sine graph. I'm trying to think of how I want to do this. I'm gonna label down here, pi over 2. This is pi. This is 3 pi over 2. And over here is 2 pi. So if I do a quick sketch of my sine curve, oh gosh, there's my normal one. This is not normal. We're going to be squishing this in. So I have my start point, my end point, and then I have halfway. I also need to figure out halfway between these 2 points as well as halfway between here. Half of a half is a fourth. So this is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. Students usually struggle with that. If you think about it like fractions, it's not so bad. All right, so we're starting here. We go up to the max, back down to the midline, to the min, back there. So we go like so. Gosh. So you can see how the sine curve has been squished in. Now you could repeat it again, and some textbooks do like you to do that. They want you to do 2 periods of the graph, which is kind of annoying, but there you go. So you can see you could fit 2 periods of this thing into the space of 2 pi. So like if you kind of split this up, that's 1 period. This is 1 cycle of the graph, okay? The last one we're gonna look at is cosine of 1/4 x. So again, our b value is 1/4. So the period of this graph is 2 pi over b, which is 2 pi over 1/4. When I'm dividing by a fraction, I'm multiplying by its reciprocal 4. So now the period of this thing is 8 pi. That's ridiculous, but it should be kind of fun, right? Let's see. Woo! We're gonna go all the way out there. Now, before you start marking off things here, think about the points that you're gonna be using, right? So we can go ahead and do our 1, our start point, 2, 3, 4, 5. Remember, there's always 5 of these points. I know I'm ending at 8 pi, and this is cosine, so it's gonna end up high over here. So I'll write my 8 pi down here. Halfway is gonna be 4 pi. Halfway here is gonna be 2 pi. 2 pi, 4 pi, 6 pi. So these numbers were kind of nice. Will it always be that way? Of course not. But for our purposes, it'll be nice. And if you want to think about what a normal cosine graph would look like, it goes 0 to 2 pi, and we can do that over here. So let's see. I'll do 1 here, -1 here, and then I'm gonna do a quick of cosine, just so you can see what it normally looks like. But we're gonna graph this nonsense over 8 pi. So it starts high up here. At the first point, it goes back down to the midline. Down here, I don't know why I wrote 4 pi down here, that was goofy. Down there, let's put 4 pi up here so we don't forget about it. Back to the midline and then up to the max. So this thing, look at this, this is wild. This is really stretched out. Okay, all right, so, wow. Normally cosine looks like this, but we've really stretched it out pretty far. So, that's kind of funny actually. We could actually fit 4 of these cosine graphs in this period of this function. Fascinating stuff. We will conclude there because we've talked a lot about the transformations with vertical shifts, with period changes, and also amplitude. Be sure to check out another video soon about phase shift. That's when we have the horizontal changes as well as a combination of all of these things. It'll be super fun. I'm Mary, and I thank you so much for joining me for this long magical math moment. Please feel free to like, share, and subscribe, and I'll see you again soon. Bye.